Hi everyone, I'm Jim McSorley, author of the McSorley 442 chassis plans and curator of Sevenesque.com. In this video I'd like to demonstrate how I got to a certain point in my build, focusing on the front suspension, how I went about designing it and building it as you see here. The coilovers I'm using are pretty common. They're from Lindblad chassis. They cost about $100 a piece. 50-50 dampening ratio is not adjustable. Fully expanded, they're 14 inches from eye to eye. Fully compressed, 10 inches from eye to eye. And I intend to run these at 12 inches at chassis height, at standard chassis height. And they come with a 1/2 inch sleeve, about 1.4 inches in width. Pretty standard adjustability here. And these springs are rates in the front. I'm running 300s for starters, and in the rear I'll run 150. This particular approach does cause some complications with the shock mount. Should the control arm cross member be in the uppermost position, the question becomes how much is it going to interfere with the shock. So there's a couple things you might notice wrong with what I'm showing right now. One of them is that I have a huge gap right here where the bracket would mate to the chassis in order to create a perpendicular shock mount. So I'll show you how I'm going to fix that problem. And then the other thing is that because of this clearance, I found that the most effective way to deal with that is to invert the coilover, which means placing it in a position like so, and therefore providing plenty of clearance in order to be able to get to the cross member, not only for drivability but for serviceability. Some people might be concerned about inverting the coilover. I'm not. It's a single tube coilover that is already under hydraulic pressure, and it's of a 50-50 ratio that's not adjustable dampener, so I'm not concerned. And if anything, it puts less unsprung weight on the tire side, and it puts more of the weight onto the chassis side. So I'm reducing unsprung weight by inverting the coilover, and that's a pretty common thing to do. So I trust that'll work. So here's a mock-up of how I plan to deal with the offset of the coilover. You can see I've created two brackets. One of them has a very elongated face, whereas the other one is a very symmetrical design. The two of them were created in such a way that they share a plane, this flat bottom plane, and so that's what's going to find its way up underneath the chassis. And because of the difference that I've demonstrated here, we could see that my mock-up little piece of wood does come off of the chassis in a perpendicular fashion. So it'll be very easy for me to mount these tabs and then grind off this excess material in order to create a very flush 45-degree oriented upper shock bracket. Here you can see how I've mounted a very thin piece of a 1-inch stock. It's sort of representing what will become a piece of 1-inch square tubing that I'll place here to create an A-frame effect. And this will then simulate the surface of where I'll be mounting the lower shock brackets. So here we see a very preliminary dry fit of the shock mounts, coilover shock. Now my concern here is about the clearance. As you can see here, there's very little space between the front of the upper control arm and the coilover. Where it mounts to the chassis is free and clear. Because I've inverted the shock, I've got plenty of clearance between the shock and the upper control arm cross member. The brackets are pretty well oriented. I think there may be some gaps in there, but they'll resolve that as I weld everything. And it's not symmetrical in the sense that the lower control arm, I wanted to bias the shock toward the rear. And so I may be able to get a little bit more out of these brackets and orient this whole shock a little bit more to the right. And in doing so, make some more clearance. So even that much should make a difference. But I will have to make the lower control arm a little bit asymmetrical by biasing the lower shock mount toward the rear. This is a more accurate representation of what the front end will need to look like. At ride height, the piece of wood represents exactly 12 inches from center to center. We know the shock that I'm working with is 10 inches fully compressed and 14 inches fully expanded. So with 2 inches up and down as specified by the book and determined by the shock, that piece of wood represents what this will look like at ride height. The lower shock mount positioning will need to be further inboard than previously thought, which provides an opportunity to be biased toward the rear even more, reinforcing the asymmetry of the lower shock mount. But now centering, and even in this position you can see that the shock's going to be nicely centered within both control arms. The angle of the coilovers in this position is roughly 35 degrees, well within range, and creating an effective spring rate based on that angle will be pretty easy math. So the only thing left to do now is tack weld everything, confirm all the measurements as we go, and ultimately insert the coilovers and then perform whatever adjustments are needed to keep everything in the correct camber and caster.